Okay. So, this is molarity 1 times volume 1 is equal to molarity 2 times volume 2. Okay. Now, here's the big caveat to when you can do this, okay? And this is super important. Only when the reactants or products are 1 to 1 in their molar ratio. Whoops. Okay, so this is talking about that balanced chemical equation, right? So when we first did the balanced chemical equation, we saw that it was 1 to 1, right? If it's not 1 to 1, you cannot use this, okay? That's super important. So, this makes things a lot easier, right? So if we have, and in this case, when we're doing it this way, we actually don't even have to convert to liters for our volume, okay? Because we have a molarity here and a molarity on bottom, the molarities will cancel out, and so we'll end up with a volume equal to a volume, so it doesn't even matter that it's not in the same unit as the molarity. Do you guys see what I'm saying? So we could have our 0.5 molar NaOH times our 50 milliliters divided by 0.5 molar HCl. These guys cancel with these guys, and these guys cancel with these guys. Are you guys mad at me right now?
You really need to find it in liters?
No. So that's the beauty of M1V1 equals M2V2. Because of the fact that we're using 2 molarities and 2 volumes, right? The molarities are going to cancel each other, right? Now again, the only time that this works, because we're doing cancellation of molarities with different units, right? You guys see that? So this one is in moles of NaOH, and this one is in moles of HCl, right? Now the only reason why we can do that is because moles of NaOH are equal to moles of HCl, because they're 1 to 1. Does that make sense? That's the only reason why we can do this.
So if the molar ratio wasn't 1 to 1, we'd have to do the dimensional analysis way to get the answer?
Exactly.
Okay.
Right? So let me just give you an example of a chemical reaction where that would be the case, right? So if we were doing, let's say we've used this one a lot. 3, 2. And I think you guys have a little bit of trauma about this problem or something resembling it, right? So you guys see how the stoichiometry is not 1 to 1, right? So you cannot use M1V1 equals M2V2 unless the stoichiometry is 1 to 1. Okay? That's super important. Oh, sorry. This is... That's what that's supposed to be. Yeah. PO4, sorry. Questions about this, you guys? Cool. So I just want to say that I think this and the stuff from chapter 8 are the most complicated stuff that we go through in this entire semester, okay? So if you guys are struggling with this, all I can tell you is that I hope by this time in the semester that you have realized that doing homework is the only way to learn how to do this stuff, right? I can show you how to do it all day long, but you will never know what you're going to struggle with until you do the homework for this stuff, right? So please, please, please start doing homework ASAP, right? Because practicing this stuff is the only way that you're going to figure out how you might trip on it when it comes to an exam, okay? That being said, when we start acids and bases next week, is it Wednesday? Holy moly. When we start acids and bases next week, I think a lot of students really enjoy this one. So hopefully that'll be the same for you guys. There is another problem like this in your solutions lab this week. This hopefully will help you figure out how to solve that. And if you have any questions, please, please, please let me know. Everybody comfortable with when you can use M1V1 equals M2V2 and when you can't? Cool.